This is the conservation of mass reteach. First thing I need you to do is write this down in your notebook. Then we'll go over techniques of how to approach this question, what it means, how to find the reactants, how to find the products, and how to determine how to use basic math to figure this out. So just remember that the rule, the law, the conservation of mass says that whatever you start off with on the reactant side, an equal amount of matter must also appear on the product side. Only time that it makes it difficult for this to be true is if any kind of gas escapes. So most of the time if you see, and I think there's a video later that Mr. Lester put in there that will show you that in order to prevent gas from escaping and to retain the amount of mass on the reactants and product side, a lot of times they use either a test tube to do a reaction, or some have some other type of closed system where gas cannot escape, because that is one possibility of a way that mass may be released. So like if you were boiling water on the stove and you measured the amount of water, weighed it, and then went to go weigh it after you let it boil for a while, you probably would not have the same amount of mass because the water vapor would escape into the air unless you had some means of collecting it and letting it condense back into the pot. That's just an example. Okay. Alright, at this point I'll assume you had this copy down and we'll move on. Okay, so the problem says if you have 50 grams of sodium reacts with chlorine to form 126 grams of salt. That great verb, reacts, that should immediately tell you that those are the reactants. So the reactants are sodium and chlorine. And then one thing we've asked you to learn are just basic compounds, some that you use every day maybe. But when it says forms or makes or creates or anything like that, that tells you that it is a product, which in this case is NaCl, which is also table salt. Okay, so the problem says 50 grams of sodium. 50 grams of sodium, you're given that. And you're also given that there's 126 grams of salt. So sodium is 50 grams. Sodium is the on the product side. So for reactant side, we have 50 grams of sodium plus chlorine, which we have no idea how much it is. Question mark here, equals 126. Basic math tells us just to subtract both sides by 50. Subtract both sides by 50 grams. And that should give us exactly how much chlorine is left over. 126 minus 50 is 76. I think that's right. Sounds good. So the answer to this question would be 76 grams of chlorine. Okay. So again, if it says it reacts, you know that's the reactant side. If it says form or makes or creates or whatever it says, then you know that that has to be the product side. Okay. Okay, number 2. You'd write this down. It states, from a laboratory process, a student collects 28 grams of hydrogen and 224 grams of oxygen. How much water was originally involved in the process? So So this one's done a little bit different from what we just did. That's why I chose it. From a laboratory process, a student collects 28 grams of hydrogen and 224 grams of oxygen. How much water was originally involved in the process? This should be a very basic thing that you're able to just knock out of the park, so to speak, because we all know that water is a product of hydrogen plus oxygen. Okay, give you a few more minutes, a few seconds to write this down. From a laboratory process, a student collects 28 grams of hydrogen and 224 grams of oxygen. How much water was originally involved in the process? Okay, let's look at this together. So I think folks have asked me this before in class. It may not have been you may not have remembered, but some folks ask me, is it possible to take water, if you're given water, is there a way to break it down and turn it back into hydrogen plus oxygen? Okay, that's what this problem is saying, that's what's happening. So from a laboratory process, a student collects 28 grams of hydrogen and 224 grams of oxygen. How much water was originally involved in the process? And it doesn't really matter if you get this wrong or not, because you may have stated, just because it gave you hydrogen plus oxygen, and you could say that equals water, that's fine. Totally fine, do it either way. Okay, so it tells us that hydrogen, there's 28 grams, plus oxygen, 224 grams, equals how much water involved in the process. So this is very straightforward, and you probably can look at this and realize that hydrogen, we know the atomic weight of hydrogen is like 2, whereas oxygen is 32. So that's why you see the disparity, that there's only a small amount of hydrogen and a large amount of oxygen in this problem. So at the reactant side, say this, and how much is in the product side. Remember, our law of conservation of mass tells us that the reactant side amount has to equal the product side. So here you would merely just add these together and you would get 252 grams equals, so the H2O is going to equal 252, because these two together give you that much. So the main idea, as I give you tips on this, is to figure out what the reactants are. Write them down as best as you can. Use your periodic table, whatever means you can, to figure out which side's reactant side, which side's the product side, set them equal to each other, and just do the math. Hope this helps. Good luck. See you tomorrow.